And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is in-order traversal, which is marked as a easy level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given one node root of a binary tree, and what we have to do, we have to find the in order traversal of it and return it into an array list. Okay, so basically we have to store the in order traversal of the given binary tree and return it. So this is what we have to do. Okay, all right, now first thing is, what is in order traversal? So in order traversal basically means it first visits the left child including its entire subtree, then visits the node itself, and after that it visits the right child. Okay, all right, so let's quickly see and understand what is in order traversal with this example. So here 1 2 3 4 5. So if I will write, it's basically left and then root. Okay, left, root, and then right. So this is what is in order traversal. Let's quickly understand this with first example 1. So this is my root node. So first of all, I have to go to the left of this one. Okay, so now after that I will go to this subtree first, and after that here again this is root, this is root now. So I have to again go to left 4. Okay, now for this 4, I'm currently at let's say root, so I have to go to its left as well. So I go to this. Now this node is null, it means there is nothing to the left of. Okay, nothing is to the left of 4. Now it means left is done. So now what I will do, I will do the root is 4, and after that the right of 4 is also null, so nothing to be done here. Now I will, let's suppose for this subtree the in order is done. So what I will do, I will move to its parent. So for this parent one 2, so for this 2 left subtree is done. So what it's the now thing root. So for this subtree 2 4 5, what is the root is 2, so store 2, and after that move to the right subtree 5. Right subtree is this 5. So again in this 5, first of all I will go to the left, and then I will go to the root is 5, and then after that I will go to the right is also null. So after that this is also done, like for 5 subtree is also done. So look, now you can see this whole subtree is done. This whole subtree is done. Why? Because let me quickly delete this. And guys, I hope you are with me till this point. And yeah, so now you will see 4 to 5 is done, so this whole subtree is done. And now what's the, like, look, for this one node, now for this one node the left subtree is done. Now it's chance for the root is 1. Let's write 1, and after that the right subtree is 3. And so again for this node 3, for this node 3 I will go to the left, so left of 3 is null. Okay, after that the root is 3, and after that the right of 3, which is also null, so nothing. So our in order traversal is 4 2 5 1 3. Okay, all right, I hope the in order traversal will be very clear to you what it is. Now let's think of this as well. Quickly I will go. So for this 8 root, I will go to the left of it. So left subtree is this. Okay. Now for this one, first of all, I will look for this one again. I am at the root. Root node is 1. Okay. So I have to first of all go to its left. Okay, I have to go to its left. Okay, so left of 1 is null, so it means nothing is there. Okay, now left is done, so I have to go to root is 1, and after that the right is this subtree 7 10. Okay, right is this subtree 7 10. So now for this 7 10 again same thing will be there. My current root is 7. Okay, left is null, so left is done. After that 7, and after that the right is 10. So 1 7 10, and after that I will backtrack. So 7 is done, 1 is done. It means this whole subtree is done. Left subtree is done for 8. So now it's the chance for 8, which is root. So I will write 8, and after that the right subtree. After that the right subtree. So again for this right subtree 5. Current I'm 5. So again for this 5 I have to first of all cover the left subtree is 10 6. Okay, and for this 10 6 I have to cover the left subtree is 6. So after that 6 left is null, so it means I have to take the root is currently 6, so I will take 6, and after that I will take 10 as well. And like for 10 right is null, so it means this whole subtree is done. Now it's the chance of root is 5, so 5 is taken, and after that the 6 is taken. So this is the, let me quickly delete all these things again. So this is the in order traversal of the second example, and we can match it here. 1 is there, 7, 10, 8, 6, 10, 5, 6. Okay, all right, so this is what the in order traversal is. Yeah. So now I hope the in-order traversal, what it is and how we can calculate it by seeing the binary tree. Like if we are given any binary tree, we can tell the in-order traversal. Okay. But now what we have to do? We have to code it. Like basically, we cannot simply tell it for 10,000 cases. We have to write the code so that that code gives me in-order traversal of all the cases. Okay. All right. So for that, how are we going to approach this? Let's quickly move to the one node section where I'm going to tell you two approaches, one with recursion and one without recursion. Okay, all right. But before that, if I have explained in order traversal correctly, please subscribe the channel and like the video. Okay, all right. So now in order traversal, and now what I'm going to do, I'm basically, look, you can see the process for in order traversal is same. Like for this one, if I have to let's say get the in-order traversal of this whole subtree, process is same. If I have to get the in-order traversal of this subtree, process is same. For this subtree 3 also the process is same. Okay, so can we use the recursion ki yeah, I'm currently at root node, so can I say ki give me the in-order traversal of its left subtree, give me in-order traversal of this left subtree. Okay, so now for suppose left subtree in order traversal is given me into an array list which is 4 to 5. Okay, after that I got the in order traversal of its left. So what I'm going to do, I will now add my current value 1, and now after that I will say ki yaar give me the in order traversal of its right subtree. Right subtree's in order traversal is 3. So this is the in order traversal of the whole binary tree which we are given. Now you can see ki yaar I'm dividing response my responses to my children. Okay, how are we going to code it? Look, very simple it is. First of all, we are going to use first of all, any root node I'm currently at, if it is null, if it is null, we cannot add anything. Okay, if it is null, we cannot add anything. Otherwise, I have to go to its left. I have to go to its left. Okay, so now after again I have called the in order function, but this time I've called it for its left. So for its left again I'm currently at 2. Okay, so what I'm going to do, and this is my answer, let's suppose. Okay, I'm currently at 2. What I'm going to do, I'm again going to call in order dot left, like root dot left. For 2, root dot left is 4. Okay, I'm currently at 4. Again, what I'm going to do, I will say ki yaar 4 I'm having at 4. So give me the in order traversal of its left. Okay, so in of its left is null. So whenever I will get a null, it means I will simply return. So this means this null is returned here. And now left subtree is done. So now root is 4, add it to my answer. And after that the right subtree is null. Okay, so nothing is there. Now for this root 4, all the process are done. So now this recursive call will stop and I will move back to the parent. So moving back to the parent, I got 2. So root left is done. Now add 2, which means the root node, and after that the right subtree is 5. Again I will roll back to its parent 1. So left subtree is done. Now add 1, which is the root node, and after that the right subtree. 4 to 5, 1, 3. So this is how we are going to code it. I hope you have got a little bit idea, and when I'm going to write the code of it, it will become crystal clear to you. Okay, all right, let's quickly see the code for this first approach, which is recursive approach. So what I'm going to do, I'm going to store one answer is equal to new array list. Okay, all right, and now I'm going to call a solve function, and I will pass root there, and I will pass my answer array list here. Okay, all right, I will initialize this solve function, and I'm not returning anything. And here it will be again node root, and another one is answer list answer. Okay, all right, so if at any point my root is null, it means I don't have to do anything, and I will simply return. Okay, all right. Otherwise, what I'm going to do, I'm going to call this solve function again, but this time for root dot left. Okay, let's quickly call solve dot solve, and here I will pass root dot left Okay, and answer array list. Okay, so now after that, when I will come to 144 line of, let's suppose for this one route, when I will come to 1 for 24 line, it means the left subtree is done. Okay, similarly for this 2, when I will come to 124 line, meaning solve for root, when root is 2 and root dot left is done, it means I will have 4 into my answer. And now I have to add the current root. So let's add the current root now. So simply, very simple, add to answer dot add current root dot data. Okay, and after that call this right side, like left is done, root is done. So now I will call this solve function again, but this time for root dot right. And guys, that is it. That's it. That's the code. Let me try to submit it directly, and I hope it will get accepted. So this is the first approach, which is brute force approach as well. And I have to return my answer here. Okay, because I have to return answer list, which I was not returning. Let's return it, and I hope it will get accepted. Yes, it is getting accepted. So the first approach is clear. Now let's move on to the second approach, which is to solve this using a stack. Okay, using stack, like I don't want to use recursion. But before that, what is the time complexity of this? Time complexity of this is basically traversing all the nodes once. So its time complexity will be big of n, and space complexity is basically I'm storing one answer array list whose space will be n at the last, and I'm also using recursion. So recursion uses stack memory, and at any point the space at max will be the height of the binary tree. So we go of n space to calculate to store our answer, and plus we go of log n, log of height for the recursive. Okay, so this is what is log of height, not log of n, like total number of nodes and its height. Okay, so this will be the space time complexity for this approach. Now let's think of another approach in which we will not use recursion. Okay, all right, so let's quickly see this without recursion approach with for this example. So currently I am at 8. Now look, at any point, at anywhere I am, if suppose I was having 5 here as well, so first thing what I'm going to do, I'm going to add 5. I'm going to add 5, and after that, uh, 5 is done. After that, I will move to the root node for this 1, and after that, I'm going to add once right. I'm going to add once 1, and after that, I'm going to add once right, which is 7 and 10. Okay, all right. So this is the simple process for the in-order traversal. Now, how can I use it without recursion? Let's quickly see. If I'm at any route, I will simply traverse it till I reach a point where root dot left is equal to null. Okay, so this is my stack, which is currently empty, and this is my answer array list. Okay, all right. So currently I am at 8. What I'm going to do, till I reach to a node where root dot left is equal to null, I will simply keep on moving to the left side. So first of all, 8 I got, so add 8 to the stack. Okay, after that what I get 1, so store 1 to the stack, and after that 1 is the last node whose 1 is the node whose root dot left is equal to null, so I will stop. Okay, all right, I will stop. Now simply pull 1 from the stack and add it to my answer. So 1 is removed from the stack and added to the answer. Now 1 is done. It means left is done. For this 1, root is also done. And now for the right. So when I'm coming to right, what I'm going to do, any node which is popped out, like currently 1 is popped out. So let's suppose if it is right. So now let's suppose there was 11 here. Okay. Now I'm currently at 1 because 1 is popped out from the stack. 1 was there and it was removed from the stack. So I will simply check if it has right. Yes, it has right. So move it to the right. Move to the right. Now I'm currently at 7. I'm currently at 7. So I will keep on moving, adding the elements of its left. Like 7, I am at 7. So let's suppose if there was another element to the left, which is 13. So I will add 11, I will add 7, I will add 11, I will add 13. Okay. But currently there is no 11 and 13, so it's only 7, so I will add 7 to my array list. But if it was 13 here, 13 was also there, I will add 13 to the stack as well. Okay, why? Because look, 1 is done, one, this node is done. After that, if it was 13, if it was, let's suppose, 12, and it was, let's suppose, 14 here, so what is the next node which is to be added after 1? Next node is 12. Next node is 12. So what I'm going to do, 1 dot write, which is 7, and keep on adding all the elements till it's left. Okay, so this is what I'm going to do, but luckily it is not there. So only I'm came to 7. 7 dot left is null. After that, 7 is added. There, 7 is added. 7 is added to the stack, and after that, 7 is popped out from the stack. 7 is popped out. 7 I'm currently at. Okay, so I will again check कि yeah, 7 is done. If 7 dot right is anything, yes, 7 dot right is 10. So simply add 10 to the stack. Okay, but if it was, let's suppose, 14 as well here, let's suppose 14 was here, so 7 is done. Now if 7 dot right is not null, yes, not null, so reach to 10, and keep on adding all the elements till it left, till the left is not equal to null. So after 10, 14 will be also added to the stack. Why? Because after that 7, after 7, now 14 is the next element which is to be added to my answer array list if 14 is there. Okay, so this is how what I'm going to do. Very, very simple this approach is. Now 10 is done. Okay, so 10 is removed from the stack now and added to the answer. Okay, after that, 10 is left and right, both are null. Okay, after that, what I'm going to do, 8 will be popped out from the stack one by one. So 8 is popped out, and after that, um, it is popped out. Now again, I'm going to do same thing. If 8 dot left, 8 dot right is not equal to null. No, 8 dot right is not equal to null. It is equal to 5. So move to 5. Let's suppose TMP was, let's suppose I'm storing popped out element in TMP. So TMP is equal to TMP dot right. I'm currently at TMP. Now I'm going to add all the elements till it's left not equal to null. If you remember the first step, I'm going to again do the same thing. Currently TMP till TMP dot left not equal to null. Keep on adding it to my answer, to my stack. Okay, let's add 5, and after that let's add 10, and after that let's add 6. Okay, now 6 will be popped out from the stack 1. So again, whenever any element will be popped out, I will simply check if its right is there. No, its right is not there. After that, 10 will be popped out again. I will again check if its right is there. No, its right is not there. After that, 5 will be popped out. So again, I will check if its right is there. Yes, right is there, which is 6. Okay. So let's suppose here it was 90, it was 18. So after, let's suppose 5 was popped out. So I will check if it's right. Yes, its right is there. So I will move to this right. TMP is equal to TMP dot right. Again, I am currently at 6, and I will keep on adding to the stack till its left is not equal to null. So 6 will be added. All the elements of these are popped out. So 6 will be added, and after that 18 will be added as well. So this is what we are going to do. But here 18 is not there. Here it is null. So 18 is not there. 6 is only element which is remaining. So add 6. So this is what is 1, 7, 10, 8, 6. So this is what is in order traversal using stack. I hope it will be a little bit clear to you, and I think it might be very, very clear to you as well. Depends on the level if you are a beginner or not. So now let's see the code for this approach as well using stack. And I agree ki the video has become a bit long, but I want to explain both the processes because it is very important problem of the interviews. Okay, all right, let's quickly see the code then. First of all, I will make a array list answer which I'm going to return. Okay, I'm going to use a stack, and stack will be of type node. If that's name is st is equal to new stack. And look, first thing first, while root dot left while root is not equal to null, keep on adding to the left elements, okay, to the stack. So while root not equal to null, what I'm going to do, st dot push root, and now update root is equal to root dot left, okay, which is the same thing which I have told you as well. So add all the left elements one by one. Now I'm going to iterate till my stack is not empty. While not st dot is empty, pop element one by one. Node tmp is equal to st dot pop. Now look, whenever any element will be popped out, it will be added to my answer array list. So simply add answer dot add tmp. Okay. After that, what I'm going to do? No, not tmp, tmp dot data, because I have to answer integer form. Okay. After that, if you remember what I told, key if let's suppose 2 is popped out from the stack, I will check if its right is present or not. So if tmp dot right not equal to null, okay, if tmp dot right not equal to null, it means right is there, 5 is there. So what I'm going to do, if you remember, I told tmp is equal to tmp dot right, move to the right and again add all the elements of it to the stack till it's left, like all the elements, left elements to the stack. For example, if 5 was there and the 7 was there, and after that 9 was there, and I am currently 5, tmp is 5, so I will add all the elements 5 7 9 to the stack. So let's code it, very simple, tmp dot right, and if the same thing is there which I'm doing here, okay, while tmp not equal to null, tmp is equal to tmp dot left, oh sorry, tmp, before that add st dot push tmp, and after that update tmp dot left. So this is what it is, and after that I will simply come here and return my answer array list. So this is what we have to do. I hope it will be very clear to you. So please sit with pen and paper and try to visualize this approach once. And if you have loved the explanation till this point, don't forget to subscribe the channel and like the video, because I'm giving my full effort. And if you will subscribe, if you will comment how was the explanation, it will really motivate me. So yeah, please subscribe the channel, like the video, comment down your feedbacks, and that was it for today. I'm going to see you again tomorrow. Till then, keep on coding and bye.